In a previous lesson, we learned about the Earth's rotation and revolution. And in revolution, we learned that the Earth orbits or goes around the Sun. Well, in this lesson, what's important for us to understand is what happens as the Earth goes around the Sun. If we look at this picture, we see the Earth, we see there's an axis, which is the imaginary line that runs right straight through the middle of the Earth. And in this picture, we can see that the axis is straight up and down. But as we've all heard, or if we've looked at a globe, we can see that the Earth is not straight up and down. It's actually tilted. Okay, it's tilted at 23.5 degrees. Okay. Now, this tilt is very important for life on Earth because when you combine the tilt of the Earth with the revolution as the Earth goes around the Sun, it gives us our seasons. So when you combine the Earth's tilt with its orbit around the Sun, we get the 4 seasons. And we're going to look in just a moment and see how this happens. We already know that the Sun is what gives us our energy. The Sun heats up the Earth. And we also know that the equator is the warmest part of our planet. The equator stays nice and warm year in and day out, year in and year out. People go on tropical vacations because the sunlight is directly hitting on the equator. And we also know that the North Pole and the South Pole are not places that you particularly want to live because they're pretty cold up here and pretty cold down here. And if we look right here, we can see that the angle of the sunlight is not nearly as direct as it is down at the equator. So the angle of the sunlight affects greatly how much energy we get from the sun. If the Earth was standing straight up and down like this because of the angle of the sun, then this area right in here would always and forever be warm. This area in here would be kind of nice, and this area up here would be very, very cold. It would never change. We wouldn't really have seasons. They would have an eternal sort of spring, early fall. They would have summer all the time, and again, spring, and then winter. But as we know, thank goodness, we have seasons. We have the weather changing, so let's look and see why that is. And of course, as we know, it's because the Earth's tilt. The Earth's tilt. We've got a tilt right here. Here's the axis. You can see the dotted lines that shows the axis. So the Earth is tilted over at 23.5 degrees. And what that has the effect of, as the Earth spins, then the equator, this area right through here, does get pretty consistent sunlight all the time. But then because of this tilt and the Earth's orbit around the sun, these areas up here also get more sunlight sometimes of the year, and they get less sunlight sometimes of the year. We've got 3 main areas that we need to know about. We've got the Tropic of Cancer, Tropic of Capricorn, and in the middle, of course, we have the equator. So the equator, Tropic of Cancer, Tropic of Capricorn. But let's don't forget, we got the Arctic Circle and the Antarctic Circle, and those will come into play in a few minutes. When we combine the Earth's tilt with the orbit of the Earth around the sun, we get a whole bunch of movement going on. Okay, now don't forget also that the Earth is spinning on its axis at the same time. If you look over here, you'll see that the Earth's tilting, the northern hemisphere is actually tilting towards the sun. And therefore, if you look at this dotted line as the major amount of sun's energy, we can see that the biggest part of that solar energy is hitting the northern hemisphere. And since we're getting more sunshine, more daylight, it's going to be warmer, giving us our summertime. All right. Now, at the same time, the southern hemisphere is tilted away. So they're not getting, if you look at this little area here, they're not getting near as much energy in the summertime, in their wintertime, as we are in our summertime. All right. As the Earth continues its journey around the sun, up here where we can see it's directly tilting towards the sun, now it's pretty much parallel to the sun. Look at this. Think of that as parallel. Both of these sides are parallel. Neither one is tipping towards the sun or away from the sun. And because of that, the entire surface of the Earth, gets the same amount of daylight. And we call this an equinox. They're getting equal amount of daylight from North Pole to South Pole. A little bit more about that in a few minutes. Then we continue on around. Now notice this angle has not changed. The only thing that's changed is the location around the sun. Now if we get over here, we can see that the northern hemisphere is actually tilting off into space away from the sun, and the southern hemisphere is tilting back towards the sun. And as we can see here, again, our solar energy, we can see we got a bigger area of the southern hemisphere being lit up, getting more sunlight and energy than the northern hemisphere. And again, we come back around to another equinox, which we'll talk about in a few minutes. Here we have some people's favorite time of year and some people's least favorite time of year. So we're going to something a solstice. We have the June or summer solstice, and we have the December or winter solstice. And that's something we're coming up on pretty quickly here. So what I want you to look at here is a solstice is affected by the Tropic of Capricorn, the Tropic of Cancer, and the Tropic of Capricorn. The sun actually, the main focus, if we look at this line here and think of that as the main focus of the sun, we could see that the main focus of the sun on the middle of the summer is way up here in the northern hemisphere, on the Tropic of Cancer. The Tropic of Cancer. The sun is shining directly on the Tropic of Cancer. Okay? Now, in the wintertime, look at this. That same focus is now on the Tropic of Capricorn, which is in the southern hemisphere. It couldn't get any further away from us. Look how far down here on the globe that this energy focus is. So that's why we get very little energy up here in the northern hemisphere, because the sun's focus has worked its way down to the Tropic of Capricorn. As we come back to the summer, we gradually work our way from the Tropic of Capricorn back up to the Tropic of Cancer. So the solstices, the summer solstice is when the sun's light's focused directly on the Tropic of Cancer, and the winter solstice is when it's focused on the Tropic of Capricorn. We talked about solstices. Now let's talk about the equinoxes. Okay, during an equinox, the sun's energy is focused on the equator, So the entire surface of the Earth is equally lit up from North Pole to South Pole. There's about 3 words here I really want you to look at and try to remember. So let's look at these. All right, we're talking about an equinox, equinox. Now, during an equinox, it's focused on the equator. Okay, the sun's energy is focused on the equator, and the sunlight, the amount of energy on the surface of the Earth, is equal. All right, we've got an equinox, which has on the equator the focus, and it has an equal amount of the sun's energy all over the entire surface of the Earth. Equinox on the equator, and it's equal. We have a spring equinox and a fall equinox. And again, that brings us back to our word equal, because the temperature ranges in the spring and the fall, they're pretty equal. Kind of neat, huh? Here we have the sun in all its glory. So let's just put some models of the Earth in place and go through the seasons, okay? As we said, the sun's energy is focused on during the winter solstice. The sun's energy is focused on the Tropic of Capricorn. And since that's in the southern hemisphere, that's going to be having most of the energy focused down in the southern hemisphere. So they're going to be a lot warmer, more energy up here. Since the focus is the farthest away from the northern, it's going to make us colder. As we continue on in our journey around the sun, now we come to our spring equinox. Again, remember, equal, sunshine on the equator, we're getting the same amount of daylight. You can see the entire surface of the Earth is totally lit up from North Pole to South Pole, and the energy is being distributed equally, which gives us an equinox. So now we're back to our favorite time of the year, our summer solstice. Now, again, the energy focus, instead of being on the equator like it was on the equinox, Now it's back up on the Tropic of Cancer. Since the Tropic of Cancer is way up in the northern hemisphere, that means we're going to get most of the energy from the sun up here, giving us our summertime. Since we're the farthest away that we can be from the southern hemisphere, they're going to be having winter. And it's very, very important to always remember that the seasons are exactly opposite between the northern hemisphere and the southern hemisphere. If we're spring, they're fall. If we're summer, they're winter. And finally, that brings us back to our fourth season. In this case, it's going to be our fall equinox. The fall equinox, again, the sun's focused on the equator, so we're going to have equal amount of night and day from North Pole to South Pole. Again, we said equinox is equator, equal night and day, and since the temperature is about the same, we can even say the temperature is equal. So everything's equal with the equinox. Okay? Here's our recap. The Earth has two major motions, rotation and revolution. Combine that with the tilt, and we have good old planet Earth with our seasons. So rotation, you see if I can do this well, is rotation as it spins around its axis. Okay? And the seasons are brought to us by the good old tilt of the Earth, and as we make our yearly revolution around the sun. Rotation, revolution, and tilt.